All right, here we are. We are about to continue our journey through a diversion away from the art of computer programming because I need to learn some more maths. And we are working on the Book of Proof by Richard Hammock. We left off having finished the first set of exercises in section 1.1, and we're going to keep working from there. I'm in two minds about how thoroughly I want to do this. I think typically I would do it quite thoroughly, but I'm not sure if I'm just, being a bit of a scrub about it. Might not be necessary to do all of these exercises, although I've probably veered more towards that, as it can be difficult otherwise to know if you've missed something important. Hello, strongly typed. Hello. How are you doing today? The audio today is different from the last 2 weeks. I thought I'd switch it up. Now we've got a bit more bird song in. Let me know if the levels are upsetting you at any point. And I've also spent the last week muddling around with my setup. You probably won't notice, but there is a slightly better camera recording me now. Still not as good as I would like, but there you go. You can't have everything work. Okay. The big image problem is always right. So it'll be another math-heavy session. I mean, we're in a math-heavy part of the book, but in particular, we may not even get to the art of computer programming for weeks now. Until I've consolidated this, we might just jump back a little bit as soon as we get to proofs and see if I can puzzle through any of the inductive reasoning or mathematical induction chapter. Okay, so what have we got here? Now this exercise, so the last exercise that we did, or I did, was taking things from this, what I believe is called set builder notation, and putting them in, some sort of hand-wavy list, essentially. And let me just check this for a second. Okay, that's fine. And this time we're doing the opposite. So we've got this type of thing. We've got to work out what the set builder notation is for it, and then put it in that. Apologies if there's any drinking noises. One day they'll invent an AI that can get rid of those. Okay. So this first one, I think, so this the structure we use. Let me make this a bit bigger, actually. Even bigger. I might have to make my head. I was contemplating making my head smaller at every moment. Okay, so 2, 4, 8, no 6, no 0. So I guess we are going to be in the, what are they called? The natural numbers? Which means we want this little symbol here. Can I copy that out? Yes, I can. Wow, it's a little big, but there you go. And I think we want to be in the natural numbers, which I think are the n's. I think it's n. N for natural. Let's go with that for now. And then my temptation is to have it be 2x, but then we're going to miss out a 3. Andre Hammers X, good morning. Good afternoon from the UK. Good morning to where you are. What's the objective in this project? So my objective in this project is to complete, let's say, an any percent run of the book The Art of Computer Programming by Donald Knuth. I say any percent because 100% will basically be impossible because there are unsolved problems in there and I don't expect to solve all of them. But I'd like to work through the whole thing and do broadly all of the exercises that are sort of within a manageable scope. This will take quite a long time. So I guess that's the objective. The purpose is because the book is, well, there are a few purposes. The book has a reputation, so that it's actually books. It's like 4 volume, 5 and a bit volumes. And he's working on a bunch more, although he's 89, I think, now. So how many of those he gets through, I don't know. But it has a bit of a reputation for being one of the greatest works in computer science literature and research, but also a reputation for being one of those books that sits on the shelf, or one of those volumes that sits on the shelf, and I think that's a bit of a shame. And so it seemed a bit like an interesting project to just work through it all, because also it's sort of notoriously difficult to work through it all. And I think I'm finding, well, I don't think I'm actually finding it yet. It's actually not that difficult to work through. It's more, it takes a lot of work to work through. So I guess my objective is to find out what makes it hard to work through, what it takes to get through such a thing as someone who just has like high school mathematics essentially and a bunch of programming experience, and to read the book. I guess read a book that people often don't read, and to try to kind of share some of the things that experience gives me. Hello, Soda444. Thanks for joining. Hello, Lazy Schemer again. Hello, Bedrodev. Yeah, Lex Friedman interviewed him. I haven't watched the Lex Friedman interview yet, but I will at some point. Andre Hammer says, oh, must be challenging. Good luck mentoring the field also, but have difficulties in more complex algorithm problems. Is morning in Brazil. Yeah. All of that makes sense. Yeah, well, there's if you stick around for a couple of years, we might get to some of the complex algorithms that Knuth has gone to pains to make clear. His objective, I suppose, is to do an overview. Well, really, to write up the whole field, which he decided to do in his late 20s, which is kind of a remarkable thing to try to do. It's even in setting the intention, I think it says something about him. Okay. So it's not this, because we're losing the 6. So what actually is going on here? Oh, well, obviously they are doubles. They're powers of, right? Power 2, power 1, power 2, power 3, power 4, power 5, power 6. Okay, I think that's right. Pretty sure that's right. Okay. 18. And actually, I've got that the wrong way round. Or have I? Does it matter which way round they go? In this side, they're like sometimes. No, the right hand side is a rule, right? And yeah, the right hand side is a rule, and the left hand side is something else. Formula or something. Oh, yeah. Wait, would it be? No, you're right. It would be, wouldn't it? Yeah, sorry. 2 to the x, so that's 2 to the power 1, 2, 3, 4, 5. Yeah, you're right. Good catch. What is the book? The book is the art of, well, this particular book is called the Book of Proof, but the ultimate book I'm working towards is reading The Art of Computer Programming. Or, it's several books. Okay, 18. Right, so here we've got these are square numbers, right? So it would be what I originally thought it was, I think. No, it wouldn't. It's more complicated than that. It's because we don't have, for example, 25 in the list. We've got, yeah, so we've got 0 to the power 2. We've got 1 to the power, no, we haven't got 1 to the power 2. We've got 2 to the power 2. We've got 4 to the power 2, 6 to the power 2, 8 to the power 2 squared. That's what they call that. And then 10 squared. So it's the even squares, I guess. So we could put this in two different ways, I think. I guess we could do that. And then we've got this symbol, which I should look up how to type at some point. And this would be the integers. So we could do that. That's probably the easiest way to do it, I think. I guess there's an alternative, probably, where you could say... I haven't seen anyone do ands yet, but you could do this. And... no, wait, you couldn't actually. How would you do that? I guess you'd have to do like a weird even thing. You'd have to do like a that doesn't seem very mathsy. That seems a bit programming-y. Let's go with that. Andre Hammer said, "You said that Donald Knuth brings problems problems never solved in this book, or he also solved them. So he has a lot of exercises in the books, and the exercises are numbered according to how difficult they are. And anything above, so they range on a scale of 1 to, or I guess probably 0 to 50. 45 and above are like unsolved problems, like open research problems. So those are in the book for you to consider and be interested in, and potentially to solve, but they're not, there's no expectation you should solve all of the problems in the book, because you would have to be someone quite special to do that. Bedredev says, so what are we proving? Well, right now I'm not proving anything. Here we are, let me actually just go there. We're on, basically the journey we're on is we're trying to get through the mathematical prerequisites section in the Art of Computer Programming Volume 1, which starts off with mathematical induction, which I just about managed to get the gist of, but not to the extent that I think I could really understand what was going on. So what we are doing in the meantime is pausing at that chapter, then doing the mathematical prerequisites for the mathematical prerequisites, or at least for me, and spending time with the Book of Proof, which doesn't even start with proofs until chapter 4. It first introduces us, I guess, to the mathematical objects necessary to consider proofs. If you watch the VOD from the last section, you'll get a feeling for why I've done this. So, there's a lot of notation there. There's a lot of like stuff there which is slightly skimmed over, which realistically I did not understand to the level that I could do anything with it. So yeah, that's part of the project. Scammed. Yeah, I've scammed you. Sorry. And now you're locked in here with me. Okay, so I think this is... I think that will do for that one. I think that's right. It's the integers because the natural numbers don't contain 0. I think that's right. Then again, there's another one, isn't there? They contain negative numbers, I think. So, all right, let's look back at this. I think we've thought carefully enough about that. Okay, natural numbers, integers do contain. So we're actually looking for we're actually looking for. Yeah, we're looking for something. This isn't the full answer. I don't know how we do ands, or even if an and is required, or if it's just implied. But let's say. I don't know. That's how I would do it. That's how I would do it. All right. I'm sure the answers. I think the maybe the only half the problems are answered. So anyway, hopefully the answers will give us a clue as to what that is when we get there. Okay, 19. We are looking at some negative numbers. We've got -6, -3, 0, 3, 6, 9, 12, and 15. So it's the multiples of 3. So is this right? Okay, I should look up actually how you... okay. Yeah, there is no special... You know what I'll need to do? I'll need to create myself a little keyboard shortcut for that symbol. Okay, what should we call it? Let's call it lm.char. So now, if I do that, then it will replace with that. Okay. What was I doing? Oh yeah, integers. Okay, I think that is right. Let's look at this one. Number 20. -8, -3, 2, 7, 12, 17. Now, how do you build that? How do you build that? Okay. I think I'm going to have to go into Advent of Code mode. Let's go with... Alright, so we are at... -8, -3, 2, 7. -12, 17. Those look pretty evenly spaced. It's really Ren says, are you familiar with finding the nth term of a sequence? If so, it would make 20 pretty easy to do. I guess you are saying this because there's some formula for doing this, which I vaguely remember must be the case. We should work out the difference, right? Between these terms, we think. It's been a while since I studied anything mathematical seriously. Well, it's not quite true, but this type of thing. So the difference between these are 5. Is that the same for this -3 and 2? Yes, it is. We can, I think that's basically it. So we are starting at, so let's say we start at 2. Well, one way to do this would be to have it be 2 minus 5n, I guess. 5x rather. I'm not sure if that's exactly the right way to do it, but maybe that would get us somewhere. In which case we would have, in fact, we need a 0 term. No, that we would get that. So we'd start off with 2 for 0. Then, well, actually, we probably don't want to do that. Probably want to have it be plus. So it'd be 5x plus 2. So we start off at that. Then we've got 5 plus 2, 10 plus 2, 15 plus 2, that's right. And then we have minus 5 plus 2 minus 2. Okay, that seems right. What did I say? There we are. Yeah, it's essentially looking at the difference between the terms and then comparing its offset to the formula. So for 3, 5, 7, the difference is 2 between each term. Comparing that to 2, 4, 6, the offset is +1, so the formula would be 2n plus 1 for all n in the natural numbers, if that kind of makes it. It does. Thank you. Thank you. I appreciate it. It's really zen. Okay. Let's say that one's looking right. Okay. Wow, that number line would have been useful, huh? Let's keep that around. Let's not delete this. I joked last time about, I say joked. Let me actually see if I can make this into something a bit more useful, actually. Yeah, what was I going to do? Yeah, can you color numbers here? I don't think you can. No, you can't. Basically, I was joking last time that all of this, the real purpose of this stream is a giant joke to see what's the most boring thing I can get people to actually tune in for. And every time I think, wow, I am living that joke. I'm the Rorschach of boring streams. Okay. Okay. That will do. And then we'll have our little markers as well. Okay, 21. Oh yeah, I need to scroll up. There we go. 21. We've got 0149. Now this won't be right because this is a sequence I recognize. Yeah, squares, right, of course. Yep. 1 squared, 2 squared, okay. But it's in the natural numbers. No, it's in the integers, but above from 0 up. I think that's right. Yeah. Okay. 3, 6, 11, 18. 3, 6, 11, 18. Okay. Let's plot that out and see what we get. Now, obviously, there's something, I mean, there's some difference. It looks like the squares again, right? But it's not exactly. It's 2 off there, it's 2 off there, it's 2 off there, it's 2 off there. It's 2 off there, and it's 2 off there, but there's no 0. So this will be in the... This is actually... x squared, but in the natural numbers, but it's x squared plus 2, I think. So if we were to do this, then yeah, let's say we've got 5 squared plus 2, we get 27. Okay. Happy Nora says, well, x is greater than or equal to 0 is technically optional since -1 squared equals 1, -2 squared equals 4. Oh, yeah. Oh, yeah. Oh, yeah, of course. Yeah, good point. Good point. Okay, yeah, that makes sense. But in this one, it's not optional, right? Because we do need to not have 0. Or rather, it is optional, but we have to take it from the natural numbers, which don't include 0. I think that's right. Yeah, okay. Got to remember the properties of squaring things. Okay. Is that true on 18 as well? Yeah. Yeah, it is as well. Yeah, okay. That is a good point. Okay, that is not what I wanted. Okay, 23. 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7, 8. I don't know. I don't know, guys. I don't know about this one. Does it have pi in it? Actually, this one, we can do it the other way around, can't we? And then we want to have that, I think. I think that's right. All right, 24. -4, 3, 2, 1, 0, 1, 2. Okay, so it looks kind of similar, but with the integers and that, I think. Okay, 25. We've got an eighth, a quarter, a half, 1, 2, 4, and 8. So, well, Oh, it's time. There's some clock tower in this. Okay, so the first three we can say it's like 1 over 2x. No, actually that's not right. It's 1 over 2 to the power x, maybe? 2, 4, 8. Yeah. And then as we go through, yeah, there's a different, we need to figure out a different way of putting those fractions as well. Okay. Let me lock into this. 1 over 8, 1 over 4, 1 over 2. Wait, actually, we just do this with, is this to the power, like, -2 or something? Or, like, something like that? I feel like I vaguely remember that. Yeah, so it's like 2 to the minus 2 to the minus 2 to the minus 1 is a half, 2 to the minus 2 is a quarter, 2 to the minus 3 is 0.125. So if we keep going, we get 2 to the 0 is 1, 2 to the 1 is 2, 2 to the 2 is 4. Okay, fine. So it's this, but in the integers instead, I think. Because then we get the minuses in there as well. Okay, it's really ran. For sequences like 1, 4, 9, 16, 25, n squared, the first difference is a 357, and the second difference is a constant at 2. A constant second difference. Yeah, I remember doing that before, about 20 years ago. Second difference tells us that the sequence is quadratic of the form an squared bn plus c. Yeah, makes sense. I'll just put this comment here as well, just so it gets into the... Oh, I almost banned you then, sorry. Okay, my client does not like copying, so... There we go. A constant second difference tells us the sequence is quadratic at the form a and yeah, etc. For such sequences, the second difference is always 2a. So since it equals 2 here, we know that the first term for the form would be n squared. For more complicated quadratic cases, you would then compare the original formula to 2 squared and compute the linear case like previously. Yep, that makes sense. Thank you. All right. 26. Now in this case, we've got a 1/3. So is that... Yeah, I think that's 3 to the minus... 3 to the... 3... so it's... I'll just write it down, whatever. 3 to the power x. I think that's what this is. And then 1 point... So 1 over 27 is... Okay, that seems about right. Okay. No, very helpful. It's really Ren. Thanks. Hello, Vakatana Tony. How's it going? All right. 27 minus pi over 2, pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2. Okay. So if we extract pi from all of those, we get the sequence -1, -1/2, 0, 1/2, 1, 3 over 2, so 3 halves. So we get something like this. So I think we want to work out this sequence and then just add pi to it. The pi just makes it look a bit weird. So I think what we're looking for here is, just move that off. We're looking for x halves, I think. So we're looking for x halves, where x is in the integers, there's integers. Yep, and then we've got I think that's right. And then in that case, we want to put, I think somebody told me how to type pi in allegedly option and P. Let's hope the keyboard shortcut doesn't do anything different. Hey, okay. I think that's right. It's really random. Does Excalidraw use Markdown or LaTeX under the hood? It doesn't use anything like that. It's not that helpful, unfortunately. X times pi over 2, yeah. Yeah, so I guess yeah, I need to have that there. Yeah, there's nothing that helpful. It's one of the reasons I'm sort of looking to find something a bit better than Excalidraw or the other whiteboarding tools for doing stuff like this. I'm in a sort of slightly unusual position as, you know, because I'm streaming this, I want it to be visually engaging, and I think me typing LaTeX for, you know, all that time will not make that much sense unless you know LaTeX. But there's not anything like really good. There's not anything obviously better than Excalidraw or TLDraw for doing this sort of thing that I've found. There's stuff with like widgets and stuff, and there's Math Excalidraw, but again, it's like you type in the code and then you get the result. There's not really a good WYSIWYG version. So my best idea so far is I've rigged up an old iPad, and so I can, if I really want to do things properly, I can do this. I can do and then if I can remember how to do the symbols. Whoa, that's not right. I think it's like, oh gosh. Then you got to learn how to draw the symbols. And then I learned how to do this the other day. Oh, you can't even see. I learned how to do this the other day. For those of you who want to draw curly braces, I've never found an easy way to, like, curly braces, I just try. I'm like, is that right? This looks terrible. Anyway, I read somewhere that for the opening one, you want to draw an S and then a 2, and for the closing one, you want to draw a 2 and then an S. And then it becomes more natural after that. But isn't that cool? That would be kind of cool. Yeah, so I figured, it's basically, I've invented the blackboard. So obviously people still use blackboards when they're teaching maths in universities for a reason. Because it's probably the easiest way to get something which is visible to people. Is it SkyDraw mainly for just writing maths? Or is this just for writing maths? In any case, this is not designed for maths. It's designed for like just putting stuff up you want to show people, diagramming and stuff. A couple of recommendations would be a drawing tablet. Yeah, Obsidian. Yeah, I've tried Obsidian. Obsidian's really good. Tipst. Yeah, I haven't actually looked at Tipst. I think I briefly looked at it, but it didn't immediately ring a bell. But I'll take another look at it. I've heard about it. Yeah, I will take a look at that. Okay. Right, what was I doing? 27. Okay, so this is my answer. Oh yeah. Wait, I've got the brackets wrong, don't I? Or do I? Does it matter? X times pi over 2? It probably is. Wow, my intuition for this stuff is terrible. Let me just work this out. Okay, so if we group it that way, we get uh, 1, 2, 3, that's 1, 2, 1, 3, 4. And then if we group it the other way, no, it doesn't matter. Oof. Okay, anyway, let's go with this. Right, 28. Minus 3 halves. Set theory indeed. Minus 3 halves, minus 3 quarters, 0. 3 quarters, 3 halves, 9 quarters, 3. 15 quarters, 9 halves. Now I bet that'll make more sense if we put it in a, this has just been useless. Why not calculus? Well, don't worry, I'm sure we'll get there. Set theory because it's, in particular set theory right now, because it's the start of the book of proof. That's where it decides to start. I made no decision to start with set theory specifically other than this book did. Okay. So if we put this in a different form, I wonder if this will make more sense. So we've got minus 3 halves. Okay, that is totally the wrong orientation. Minus 3 halves. No, wait, we want to have this in quarters, so 6 quarters, 3 quarters, 0, 3 quarters, 3 quarters, 6 quarters, 9 quarters, 12 quarters, which is 3, which we can verify by saying 3 by 4. Okay, that makes more sense. So this is going to be 3x over 4, where x is in There's integers. Okay. Okay. Let's check the answers. Which are somewhere else. You know, one of the great things about the PDF of the Art of Creative Programming is when you do the exercise, it will link you to the answer. You just have to click it. But we're on page 7 at the moment. Okay. Okay. 17. 2 to the x in the natural numbers, that's correct. 19. 3x with x in the integers, that's right. 21 is x squared, where x is in the integers. 23 is x in the natural numbers between 3 and 8 inclusive. Inclusive, just to do some retrieval practice here. Inclusive, we're talking about an open thing. Open range, open set, open something. It's open because I'm putting my hands around and saying, come into the range. Okay. 25 is 2 to the n, where n is in there's integers. 27 is k pi over 2, where k is in there's integers, and then 28 is not specified. So all of those are correct. Well done, chat. Well done, me. Team effort. Okay. Page 7. Okay. Closed interval. Wow, I was wrong. Let me refresh that then before I consolidate myself poorly. I was wrong. I knew I'd get that wrong. I knew I'd find that terminology confusing. Okay, closed interval. No, wait, I remember why it was. It was closed interval because I'm closing my arm around the number and saying, come into the range. I am being open-hearted, but it's a I'm closing it around, you know, closing my arms around the range. I don't know how I'm going to remember this one. I'm always coming up with the mnemonics that just make sense both ways. Okay. Okay. Now this one I was looking forward to. Cardinalities, I don't know. I feel like the cardinalities will kind of make sense. But it's probably going to find ways to be confusing anyway. Okay, let's get this loaded. All right. So I think we're just finding the top level cardinality here. So we just need to count the braces, right? So open, open, closed, open, open, close, close, close. 1, I think. That didn't actually help at all. That just validated that it was the correct syntax, which obviously it is. Okay. Okay. Well, I guess if we get to 0, then that'll mean we can add 1, right? So let's try this again. Okay, open, open, close, skip, skip, open, open, close, close, open, close, close. So again, it's just 1, right? Or am I a level too far down? Yeah, I should be counting the outer one. Yeah, that probably makes sense. They all starting with braces, aren't they? So it's the outer one I need to consider differently. Okay, so it's actually okay, so that makes sense. Right, so we've got open. So it's when we're here is we need to count. Open, open, close. That's 1. This is not helping at all. Okay. Okay, all right. Let me draw boxes around these. This will be way better. This will be way better. Okay. Okay, that's 1. No. That's 2. And that's 3. This is 1. This is 2. And this is 3. And this is 4. Yeah, 3. Yeah, cardinality means number of elements in the set, and the thing that's they're trying to trip us up with here is it's the number of elements in the outer set, not the number of elements overall depth-wise. We're interested in the number of elements in the outer set. So, okay, 1, 2, 3, 4, 5. I need to make this a bit easier to see. Okay. Okay. No. Let me lock that. Okay, now here we've got a funny case where we're going open, open, close, open again, close, close. Ugh, need syntax highlighting for this. Okay, we've got I think this is all 1 item. Yeah, I think that's 1. Yeah. Yeah, because within it we've got this one. Let's make this red. And then we've got this one. And then we've got this one. But this is all wrapped in a single set, right? Yeah. Yeah, Lisp uses win at this part of the book. Fun fact, coming up in my current research, the guy who came up with, let's say, the idea of the electronic spreadsheet, I think he may have had some contact with McCarthy, the Lisp guy at MIT. I think it's MIT that he went to. Yeah, definitely worked on APL, but he had a bunch of experience in what were then called, I guess, like end user programming languages. And it kind of makes sense if you look at the way spreadsheet formulas work, that they kind of work a little bit, not exactly like Lisp, but they're expressions. Everything's an expression. The more I research spreadsheets, obviously it's a kind of a it's a bit hackneyed at this point to say this, but people dismiss spreadsheets, and then if they're like, wise, they'll be like, actually, spreadsheets are great. And then if they're even wiser, they'll be like, no, actually, spreadsheets are terrible. But I'm on level 4 where I'm like, no, actually, spreadsheets are really good. And nobody, though many have tried, has yet created anything as good as the spreadsheet for the spreadsheet's ultimate purpose, which is the spreadsheet's ultimate purpose is actually what I'm doing right now. I've actually considered doing this in a spreadsheet. It wouldn't really work for a few reasons, but like the spreadsheet was originally termed, it was originally conceived as a magic blackboard to replace or to kind of do a lot of the work that blackboards were doing in Dan Bricklin's time at Harvard Business School, to be a whiteboard that you could calculate on, that could do computations. In a way, it's like what I'm looking for, ironically, in this project is exactly what I'm researching in another project I'm doing, which is a magic blackboard that could do calculations for you. But still, we have the spreadsheet. The spreadsheet isn't quite right for this sort of thing, but we really haven't advanced from that point in what Dan Bricklin was trying to do. Yeah, similar to a matrix, but it's actually, yeah, I mean, there's a whole video coming on what the spreadsheet is, and it is a matrix, but it's also a whiteboard. Additional fun fact, spoilers here, is that the first version of the spreadsheet, the first conception of the spreadsheet by Dan Bricklin, did not have grid lines. There were no columns and rows. He added grid lines as an analogy to the map, so that you could locate things on the screen. And then, due to the technological constraints of the day, the grid became quite key to the interface. But it wasn't initially there. It was added so that you could locate numbers on the screen you wanted to calculate with. But originally, it was going to be something like much more sort of out there. He imagined a heads-up display. He imagined it having a heads-up display like a fighter jet. Anyway. Okay, cardinality. If anyone knows Dan Bricklin and wants to put me in touch with him, I keep saying this just in case anyone does, please help me. I want to talk to this guy a lot. Okay. Where are we at? Okay, so we're in here. Open, close. Open, close, open, close. I think this is one element as well. Let me just make the little elements. Okay, so we've got one in here. Then we've got those two. Then we've got this one. And we've got this one too. So I think this one's just 1, 2. Or is it? No, it is, because we've got these braces around the outside. And inside these braces, we just have one element, which is this whole, God, this is like, this is a complete waste of time. No, it's not. It's kind of fun, but ultimately it's not like, the work of this is not actually to parse confusing expressions. I guess it would be, if you're trying to teach this sort of thing, you would get wrong unless you did understand the point, which was, it's the outer elements you're counting. Okay, here. So in the integers, the elements where the absolute value is under 10, which would be -9 all the way through. Yeah, so it's let's go up. We've got 0. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we've got the same going negative, which means we've got 1, and then that's going to be 9 elements. And 9 elements here. So it's 9 plus 9 plus 1, which is 19. I think. Okay. Let's go 34. Now we're in the natural numbers, where the absolute value is under 10. So this will be 9, because we only get 1 through 9. (35), we get x squared under 10 in the integers. So again, we've got to consider the negative numbers here. So we've got 0. We've got 1, 2, 4. 2 squared is 4. No, wait. 1 squared is 1. 2 squared is 4. 3 squared is 9. It's amazing that I get through as much material as I do. Okay, and then we've got these. Wait, what am I on? 35. Okay, this one. In the integers, we've got 1. So, gosh, okay. 1, 3, 3. That's 7, I think. Matt D. I've personally thought of them as ways to view and manipulate data. If you're after a magic whiteboard, there's a few tools like Miro that do that concept far better than a bare spreadsheet. So yeah, I mean, you're definitely right now, though the original creator, designer of this first spreadsheet wasn't thinking in those terms. Well, not just in those terms. Obviously, there wasn't Miro back then. It's just interesting that that's where it came from. And I still think it's better at, like, if you use spreadsheets in a business, for example, you will notice that they end up as much presentational as they do about calculations. And often if you use them yourself as well, like people do all kinds of weird stuff in spreadsheets. People write scripts in spreadsheets. People do all kinds of strange things. And the thing about Miro still, and the thing about tools like this, is you still can't really calculate in them. You can't program in this at all. Like there's no programming tool in Excalibur or really Miro. I mean, you've got an API, and there's like widgets, but they're not. You can't program in them in the same way you can in a spreadsheet, which is interesting because I you know, there are other. I wonder if people have probably tried that, but yeah. But I've also done unholy things with Miro as well. Some of the things I've done with Miro. Excel has baked in Python compatibility now. That's cool. That's cool. That's cool. I think even the first spreadsheet, arguably the first spreadsheet VisiCalc had macros, but they were in some sort of loader. I need to research that at some point. Oh, Claude 2, yeah. I opened up Xcode. Always a mistake. Always a mistake to open up Xcode yesterday. Yeah, it's got agents in it now as well, which is fortunate. Okay, all right, back to the regularly scheduled mathematics. Okay, in the natural numbers where x squared is less than 10, so natural numbers don't include 0, so we've just got 1, 3, and 9, I think there. No, wait. Wait. 1, 4, and 9. 1, 4, and 9. My camera is threatening to get upset about temperature. We'll see how that goes. Turn that off. Okay. If I disappear and become a faceless YouTube channel for a little bit, then the microphone will work fine. So we'll see. Okay. Oh wait, 149. So that'll be 3 for 36, I think. And then 37. We've got x in the natural numbers, x squared under 0. That would be a cardinality of 0, I would think. I don't think there's anything that meets that description in the natural numbers. Okay, and 38, x in the natural numbers, 5x less than or equal to 20. So for that, we've got not 0. We've got 5, 10, 15, and 20, which means we've got 4, I think. Okay, I think that's right. It's really Ren is saying, in fact, I'll look at the answer before I engage with any conversation about AI. Okay. C. We're on page 8. One day I'll be straight there. Okay. 29. 3. 31. 1. 33. 19. 35. 7. 37. 0. And all the others are unspecified, so that looks about right. Now, am I going to do the sketching ones? Yeah, one thing in relation to what you're saying, it's really Ren. I don't know. Every time I feel this, every time I hear this in my own mind, I think, am I just old now? Because I feel like all tools above a certain level of like complexity are becoming a lot worse now. Like, I'm never someone who's like, been like a massive like Vim head or really place that much emphasis on like becoming good at those tools. I don't have anything against people who do. It's just, for me, I try to keep my tools reasonably accessible to a broad audience because of what I do. I'm an educator in all spheres of, well, not all spheres of my life, but I'm paid for it, and I don't really want to be that impenetrable. So I try to keep those things kind of everyday tools anyone can pick up. And also not distract learners by, I used to teach total beginners, and if I use something like Vim, some of them would make the mistake of trying to waste their time learning it when they should be learning to code. And I'm sure some people had great experiences doing that, but a lot of people just, it would be a complete waste of their time. Anyway, but now I just can't stand using VS Code anymore. It's just diabolical. Like, it's not that I want to switch to like a console-based editor. I'm running away from like the AI-ification of my tools to try to get to something which is like simple enough that a person could understand it and not have, stripped back from all of that stuff, because you open VS Code now, you've got like 8 different of the same icon trying to get you to use like 3 different agent products. And it, like, please install this extension. Have you considered sharing telemetry data? Oh my gosh, it's awful. So I actually really started in earnest that maybe the best way to actually show people coding now is to use a terminal-based editor. So I'm gonna have to learn. I have to humble myself, and there'll be some streams at some point where I can't type, which will be hilarious to watch and awful to be a part of. So, but I feel that's the only way now. I feel like we're gonna like, you know how like you can trust that like images were more or less not AI generated if they were before 2023 or something. Now I feel like all my tools have to they have to be like used, like created before 2023, or I just like I feel like they're not, they're just a bit like janky. Like I'm nothing against that stuff. I've actually nothing like AI, of course, has impacts on society, and you know we've got to be realistic about what those are. But I'm not averse to using AI at all. I use it. I teach people to use it better. So I'm not against it, but it does feel like, unfortunately, the consequence is all of my tools are getting worse and worse by the month. Yeah, there's always Sublime Text. I mean, yeah, I really could see myself going back to Sublime Text, getting that license. Yeah. Yeah, VS Codium. Yeah, someone I work for, organization I works for, uses like an open source version of it. But even that's pinned on an old version as well. Hello, Wistras. Yeah, Visual Studio is a free thing. Oh yeah, maybe you go Visual Studio. At least if it's, yeah. I feel like I don't know, but I feel like we could be getting like a resurgence of, you know, the artisanal software. Like we could be going through like an arts and crafts type movement soon, where, you know, we want to use software which has not had AI touch it, which will be interesting. Even as we use AI probably to do a lot of our own work. Yeah. Emacs, yeah, Emacs is the other. I should look into Emacs. Yeah, I might break out a keyboard. Might get more keys. I could do with more keys. Maybe I'm becoming like someone I never thought I would become. Anyway, all right. I gotta get something. Yeah, I watched a stream the other day. I can't remember the person's name, who was using a nano-like editor, and I was like, oh, maybe that's all right. I could possibly use that. Okay. Anyway, I gotta get something done. Sketch the following sets of points in the XY plane. Great. Sketch the following sets of points in the XY plane. Of course. Of course I'll do that. Nope. Okay. Actually, we probably don't want to do it that way. We probably want a negative section, and we want something nice and not sloppy. Turn sloppiness down to minimum. Is that even visible? I hope so. Let me make these a bit thicker. Okay. Now I'm going to have a bunch of these, now I think of it. All right. Okay, let's go. Let's make ourselves a little template and say, let's make it from +5. I'm sure there's a way you're supposed to do these. At school, maybe this is just a teacher thing, but at school they're always like, you have to do things according to the rules. Now that I'm an educator, I know why they did it. It's because they can mark faster if everything is the same. But I'm sure there's also, there is also some utility to that. Okay, let's have this be the template, and then let's get into this and see how useful this will be. Okay, so let's have this be 39. Okay, xy, where x is... In fact, we'll probably use the pen for this. X is 1 or 2, but that's in a square bracket is... Let me take a guess. Square bracket is closed. No, wait. I know how I remember this. Somebody said something last stream. Open bracket is closed, aka inclusive. Yeah, round bracket is closed, aka inclusive, because you would have a round bracket with infinity, and the infinity symbol is round. So you would only ever have a round bracket with infinity, which means the square bracket must be open. If you're watching this and thinking, oh, of course, don't wait till you see if I get it right first. Okay. Let's see. Let's try it out. Okay, so I'm going to need some... I'm going to make this... you know what I'm going to do, actually? I'm going to do this... Hello, Atom Fighter. I'm going to do this... I'm going to make myself a little... like... There's got to be some sort of... image I can copy-paste. Apparently there are no images. Okay, I just... Okay, this is really irritating me now. Alright, coordinate plane, that's what we call it. Coordinate plane. Coordinate plane. Okay. 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 Now I don't have to draw this every time. Every day I try to make my stream more boring than the day before. Okay, alright, so now we can do this. Alright, so 1 and 2 closed. Closed means I'm closing... No, wait, I'm closing my arm around the range, so close is inclusive, obviously, because otherwise there'd be nothing in there. 1 and 2 and 1 and 2. Okay, so x 1 and 2. That's here. So we want to be here, 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 and here, I think. Those are a bit thick, actually. Make these red. Wow. Okay. Go thicker. Fine. Whatever you say, Atom Fighter. Oh, okay, that's too much. Okay, we can compromise. We can compromise on this. Okay, that's that one. All right. Okay. That's 39. Let's go 40. Now, Come on. Oh, it's the, okay. 40. 0, 1 and 1, 2. 0, 1 on the X. So that would be 0 on the X and 1 on the Y. 0 on the X and 2 on the Y. 1 on the X and, yeah, okay. I think that's that. Unlock. Okay. $41. Okay, now Y is set to 1, so we're going to be on this line. No, that is too thick. This line, and we want X to be at -1 and 1. So I think we want these points. Fun fact I learned recently is that Steve, the gentleman who works on TLDraw, an alternative to, well, TLDraw is in some ways an alternative to, I should say, by the way, I'm I'm always at risk of advertising whiteboard tools. I'm not trying to, but I do know some of the people who work on TLDraw. I don't know the people who work on ScaleDraw, but the Steve, the guy who heads the company, who is TLDraw, which is an alternative to ScaleDraw, but also a whiteboard SDK, which is pretty cool. Did the handwriting, the handwritten ink behavior for ScaleDraw as well. So I guess he worked on ScaleDraw first. I think that's correct anyway. Don't quote me on it. X2, so X is 2, and then Y is 0 and 1. Aren't I missing a point here? On 41, Happy Nora, is that right? -1 and 1. Y is 1. Oh, it's a range. Of course it's a range. Yeah, you're right. Yeah. I was reading those as arrays, wasn't I? Thank you. Yeah, I was reading those as arrays, and they're not arrays. They are ranges. Are they ranges, actually? Is that what they're called? They're like ranges. Intervals is what they're called. Intervals. Intervals. Okay. It's really Wren says, you know how you mentioned before you're trying to find the best maths writing tool for a stream? Obsidian has a plug-in to insert ScaleDraw drawings. Yeah, I've looked at it, Scalamath or something, and then you can write inline latex. Yeah, I've seen that. I didn't. Maybe I'll try it. Maybe I'll try it. I wasn't immediately. It was an interesting experience, I must say, looking at that plugin. Like, very cool plugin, but clearly a work of extreme passion by its creator, and it really comes across. Like, that is, yeah, I think it comes with like video tutorials and everything. Like, he's got his own whole thing there, which is cool. He's like created his own whole product around it, which is, yeah. But it was interesting. You don't see a lot of software like that these days. Okay, 43. I was just laughing at Eigentourist's comment about, I've been missing a point in almost every one of these streams I've stumbled into since I joined Twitch. Yeah, me too. Okay, what was I on? 43, 42, 43. Okay, and we want to be at the absolute value. So the absolute value of x should be 2, which means that we should be here or here on the line. And we've got 0 and 1 as our ranges, which means, and those are closed ranges, which means we include both of those elements. So I think we want to be here and here. It is serious work, lazy scheme. I know. The thing is, somebody had to make all of this up, and I don't know who made all of it up, other than of course Richard Hammock, who wrote it down. But somebody had to invent all this stuff. We didn't come into the universe with this stuff. I'm disrespecting their work by laughing while this is probably someone's greatest work in their life was to come up with this notation. Okay, 44. We're in the real numbers. The real numbers are, they've got like decimal points and stuff. So it's x and x squared. So is this going to be an infinite set of points? X and x squared, where x is in the real numbers. I think that's right. I'm still getting my head around what the real numbers are. I think the real numbers are... Yeah, anyway. So let's plot ourselves some. X on the x, which means this will be this and this. So we'll have this. X here, we would get... So not that. We would get this. And then we would get something else up here. And we would also get, for this, we'd get 1, and for this, we'd get 1. And then I guess, you know, there's a 9 up here or something as well. So I think I could be wrong here, but I think it's probably something like this, you know, what the square, y equals x squared type of thing. I think their point, says Atom Fighter, I think their point is that functions are relations. That sounds like it could be true. Let me just check I'm getting the real numbers right. Real numbers, oh yeah, in fact it doesn't even say what the real numbers are. But I think they're these. So you'd have to do like lots of points, right? You'd have to do like a bajillion points for the squares and stuff. Something like that. That type of thing. If I'm right. Real numbers, according to AI, are the set of all possible numbers that can represent continuous quantities. Okay. Including rational numbers, fractions or decimals, and irrational numbers, non-repeating decimals. Okay, fine. So I think this is right. Okay. Okay. Got it. Okay. Where was I? Okay, that's 44. Assuming that's on the right track. Let's look at 45. Now 45 is saying we got x, y, where x and y are in the real numbers, and x and y, x squared plus y squared, are both 1. Thank you, Icontaurus, for the sub. X plus y. X squared plus y squared is 1. Do I know the shape of that? Let's say if we have 0, for example, let's say x is 0, x squared will be 0, y squared will have to be 1, which means it will be here. And then if likewise here, so those are 2 points that we'd be at. And then we'd go somewhere between here in some way. Let's say if x was, let's make ourselves a little bit of a tiny, that's too big. That's too big. Can't make it any smaller than that. Okay. Let's say we're at 0.5. So we're at 0.5 on the x-axis, which means x squared will be 0.25, which means y squared will have to be 0.75, which means we need to get at the square root of 0.75, which is 0.86. So we want to be around 0.8 here. So I guess we probably end up doing something like this. Like a little curve in there, maybe. I will enjoy Jeff's money. Oh yeah, the squares of... Yeah. Nereidol, thank you. The squares of negative numbers are positive. I'm always forgetting that. Okay, alright, so with the... Yeah. So likewise, let's say if we've got y as -1, then x will have to be 0. And likewise here. I could just graph this, of course. There's a graphing thing. That would probably be easiest at this point. Okay, so this would be... What would we do this? Now really, you guys are not going to believe this. Well, you will, obviously. If if you're brave enough to be posting in the chat, you will expect this. I sort of wondered. You seeing this? Incredible. Incredible. Wow. I always wondered how you did circles in graphs like that. Huh. Well, it's like that. It's it's probably asking us to make this like, oh gosh, I've just moved my graph around. It's probably asking us to make this like continuous, like by drawing a line, because it, we would this would be the same thing. I kind of feel like mentally I want it to be like loads of like an infinite number of points, but I don't know. Maybe that's immature. Maybe that's mathematical immaturity to say it's an... Because for me, if a set has elements, we've got to be thinking about each of these elements like individually, as individual elements. And so it'll have a cardinality of infinity, but maybe that is... I don't know how a mathematician would think of something like that. This is problem number 45. Okay. Nimidol says you can derive this from the identity sin squared. Is that sin squared or something else? Sin squared plus cos squared equals 1. For the x squared plus y squared equals 1, if you let x equals cosine theta and y is sine theta, you get the popular identity. Okay, that's the same thing. Interesting. That mathematician was Gregor Cantor. He came up with this, or noticed this. When drawing, Naomi Doll says, when drawing it should be a solid line because the real numbers have no gaps, even though each element is separate. Yeah, I guess you're probably right. I mean, you are right. Yeah. It should be a continuous line, really, is what it should be. Okay, well that was interesting. How exciting. Atom Fighter's saying the next one is a full circle. Let's take a look at that. Okay. I don't think I can reply to that. Yeah, don't tell too many horse jokes on the stream because I will. Something about horses is just pretty funny. Oh no, it's not even horse. I know it is horse related. Cantaloupe is a fruit though. Okay. Okay. Right. So this one, 46, is the same, but it's less than or equal to 1, which makes sense. It would be a filled circle, right? So I guess it would look like this around the ones. If I was on TL draw here, I'd be able to fill this circle in properly, but maybe I can here. I can, perfect. Okay, interesting. And then I guess if it was less than 1, it would be exactly the same, but just slightly smaller, or not smaller at all. Also known as a disk, circle is technically only the edge. Huh. Now that is worth knowing. Disk. Okay. All right. 47. Let's look at 47. I'm gonna see what 47 has to teach me. Okay. 47. XY again, where x and y are in the real numbers, and y is greater than or equal to x squared minus 1. Okay, so let's say let's say for 1, x squared is going to be 1, minus 1 is going to be 0, and y is then going to be greater than or equal to that. So it's going to be this whole line, right? I think. Okay, now for 2, yeah, where x is 2, x squared is going to be 4. So we're here. No, wait. I've got this wrong. Okay, so we've already said x is 1 here for this first one. So x is 1, and then, yeah, so y is greater than x squared, which is 1, minus 1, which is 0. Okay, so this is going to be this section here. Okay, and then, so for where where x is 2, no, where x is 2, 2 squared is 4, minus 1 is 3, so we're going to, oh gosh, okay, we're going 3 here. And then I wish I had a bigger number line, bigger grid. Could I get a bigger grid? Maybe I could get a bigger grid. They don't go up beyond 10. Oh, here we go. Okay, let me try this again. Pay no attention to that. Okay. All right. So here we're going. Okay, it is technically watermarked, this image, although it's not very well watermarked. Okay, so then we are here. And obviously there's continuous points in between, but I'm just getting the shape of it. Then we are here. And then we go off the top of the graph. So I guess we're going something like... So we end up here. We end up here. Is this round? Should be. There we go. So we're ending up with something like this. And then 0, where x is 0, where x is 0, x squared is 0, minus 1 is here, so we're going to end up at that point as well. So we're going to end up, and this is where y is greater than, okay, fine. So we're going to end up here. And then something like this. Obviously not exactly like this. And then since it's squared, it should probably be mirrored on the other side as well. Let's just check that. So where x is minus 1, squared is 1, minus 1 is 0, so we end up here, and then, yeah, so that's the same. So we basically just want to mirror this, which we can do using this graph. Something like this, but obviously with all this colored in. So I guess I can make this into a shape now if I like. I've not been looking at chat at all, so you may be saying, whoa, why have you gotten this so wrong? Okay. That's not what I want. Anyway, you get the picture. Draw this in. Can't even do that. Draw this in. Somehow. I think. Okay. Yeah, what number was that? 47. Wow, it's really small now. Okay. Let me make this bigger. Journey to the center of the earth. Okay. What's chat saying? Okay. It's really Ren. Good to have you. Glad to have you here. Have a good rest of your day. Okay. Right. That's what we got. Just got to I won't comment on usernames too much, but just got a follow from a gambling ad. If you're there, gambling ad, great username. Great username, really off the wall. I like it. Okay, 47, now 48. Let's go do 48. In fact, I'm going to make this little thing here a bit easier to, a bit more ergonomic. Okay. 48. Okay, often, so RCRNSTN says, often it's useful to graph the equality and then going, the points of interest lie on one side of option including this curve. Okay, that makes sense. Right, so yeah, okay. So we graph it as if it's equal and then sort of look at what way it's going. Okay, that makes sense. Right, 48. X and Y in the real numbers where X is greater than 1. So where X is equal to 1, as RCR said, where X is equal to 1 is this. So I guess it's all of this area. And beyond. That's a greater than rather than a greater than or equal to, but I don't think it makes any difference. I guess we just don't want to we don't want to quite touch the 1 point, but I guess it probably doesn't make any difference. Okay. Let's keep going. 49. X and X plus Y. So we've got something at the start now where X is in the real numbers and Y is in the integers. Interesting. Okay, let's plot a few of these. So let's say X is 1. Then and Y is in the integers, so Y could be, let's say Y is 0. In this case, it would be here, but it could also be, well, that's not right. Okay, let me make that opaque again. Oh, whatever. It could be here, it could also be here, it could also be here, and it could be at all these points, I think. But it can't be in between them because it's only integers and we've got no fractions or anything in there, I think. But X is, no way, it can be between them because X is a, wait a minute. So X is in the real numbers, so as we go across, we're going to end up going up diagonally, maybe? Yeah, so we couldn't, I don't think we can get here. I don't think we can get there. Or we could get there, but only if it was on a diagonal line here, I guess. And we probably wouldn't end up with that. So let's say x is 0. Or let's say x is 0.5. Let's say x is 0.5. And we could have 0.5 plus 0. Which would mean we get here. We could have 0.5 plus 1, which means we could be here, and then here, and then here. And so I think we end up, apart from obviously not with a horrible, horrible line, which I can't turn the pressure sensitivity off on, but I think we end up with this, and I think we do get gaps. Because there's a real part of it, I'm tempted to say that we end up, like, my intuition is saying, well, you should end up, with a complete block, but I don't think we do. I don't think we do. So I think we end up with lots of lines that look like this. Etc. Wish I had my smaller graph paper for this. Yeah, basically this, I think. We end up with something like this. Wow, I have no idea if this is right or not. But yeah. This is what my brain is telling me. Most boring stream on Twitch available. If this isn't right, this will be even funnier. I'm going to do it before I find out if it's right. People just rage quitting. Okay. All right. All right. All right. 49. 149. X plus, oh right, okay, so Wistress is saying x equals 1 should be dotted to signify the lack of equality on the graph. Okay, interesting. Okay. Master XD, yeah, I'm doing well. How are you doing? Okay. Okay, got it. Dash curves when the points of the curve are not part of the set. Okay. I think this is probably right. Well, it probably isn't right, but whatever. It was fun to do. Okay, 49. That's 49. Let's get these done. Let's get these done. 50. Am I going to want a big or small grid for this one? Let's go with small. No, that's the big one. Let's go with small. Okay, 50. So for this, x is in the real numbers and y is in the natural numbers. Natural numbers don't include 0 or below. So Well, it's just handy because otherwise we'd be dividing by 0. Okay. So let's say x is 0. Start off with 0. X is 0 and 0 squared is 0. 0 over... we don't get to constrain y by any of that. So let's say x and y are... No, wait, we do. So we've got 0 over... Let's say we'll start with y being 1. Now that's not the real y on the graph. That's the y in the formula. So let's say x is 0 and y is 0. No, we can't have 0. Y is 1. That would be 0 over 1. 0 divided by 1 is 0. So we're at the origin, right? I think. Okay, so given that, let's go with where x is 0 and y is, well, it'll actually be it'll actually be only that. We'll only be at 0. So let's say x is at 1. If x is at 1, then x squared will also be 1. We can divide this by 1, which will get us a 1, 1, so we end up with that. Now, if y was 2, we would end up with a half, so we also get a point at a half. And we get a point at a quarter and an eighth and a... That's weird. That's kind of weird. And x is in the real numbers, so what is it like? Does it look something like... Okay, so we're squaring it and then dividing it by y. So the square will always be... The square will... Oh god, so annoying. I need a smaller brush, which means I need to zoom out. That's better. Okay, so then we get this. We get this type of thing. It passes through 1, 4, and 9. So something like that. Oh, that looks terrible. Let's say, just move around like that. Yeah, you get the idea. And then do we get like a bunch of different lines coming off of this? It will be half of that, so it would go through 1.5 then at the same point. And then it would go, I guess, up here. And then this would go through 3 over 3, which is 1. And then this goes through 3 over 4, which is 0.75. Got to start remembering those. So does it look like salad fingers? Anyone remember salad fingers? Sound off in the chat if you remember salad fingers. Half of 4 is not 1.5. Good point. Yeah, half of 4 famously is 2. 4 over 3 is 0.75. And then we have more after that. I guess something like this. Okay, and then if x is in the real numbers, then it can be negative. So we have the same flipped, I think. I think that's roughly right, but of course with like more lines. An infinite number of lines, I guess. Maybe something like that. What score do you think I'd get for my homework if I handed this in? Okay. What are we what's chat saying? For 50 and the previous ones, this is yarn 1112. I think they're trying to get you to notice a pattern where the set is of the form x, something which depends on x and y, is an integer parameter. Yeah. Yeah, we will see, I suppose. Also, technically for 50, the slopes near 0 are not what you have. Yeah. So where x is 0, so the point and the origin is correct. But let's say we have like 0.001. Well, let's say 0.1, 0.25, let's say. 0.25, so let's say x is 0.25. Let's say we square that, we get, yeah, a lower number. We get 0.0625. And then let's say that's, over 1. And then if we increment that very gently, yeah, I'm not going to be able to visualize that at all. I'm going to need to graph it out, aren't I? Let me do that. Well, I'm not even good enough at graphing to get that right. Yeah, no idea. Okay. It's a family of parabolas. Yeah, makes sense. What are the regular timings for these sessions? I don't have a regular schedule yet because I'm trying not to overcommit, but it's usually Thursday afternoons, London time. So now, RCR says, one more meta question. How much effort is required to graph it can depend on if you, 1, take a single x and look at all the corresponding y's, or 2, take a single y and look at all the corresponding x's. This is more or less the same as swapping 2 for loops in programming. Interesting. Yarn1112 says, the way to think about the slope is that near x equals 0, the y coordinate is just so so small, much smaller than x. So all the curves should be horizontal as it passes through 0. Yeah, that makes sense. So these need to be flatter, basically. Yeah, okay. So something a bit more like the others, I guess. And then this goes through, what's this going through again? 2. This type of thing. And then this has got to be really, and this goes through 4, that type of thing. Probably still not right, but closer. Within my drawing fidelity anyway. Wow, really need to have some better tools for this. Terrible, terrible. Oh, okay. All right. Now, let's make all of these green so that they match salad fingers. Okay. Well, it'll be interesting to see the real version of that. There we go. Okay. Now, oh gosh, okay. Oh my gosh, okay. Come on. Oh wait, I locked that, didn't I? Right. 51. So we're thinking this will be in a similar form. Okay, so here we go. We've got x and y. X and y are elements of the real numbers squared. Now, is that supposed to indicate that it's like pairs of real numbers? Let's hope, because I don't know what that would mean otherwise. And here we've got a situation where x minus y multiplied by, y minus x multiplied by y plus x is 0. Okay. So in this situation, one or both of those pairs will have to be 0. In order for us to get 0. So one situation in which we could have the left-hand bracket be 0 would be where x and y are the same number. So if x and y are both 2, then we could have, that point's a bit small now. If x and y are both 2, we could have that. And also, if x is negative y. So if y is 2, then x was negative 2. So let's say y is 2 and x is negative 2. So we could have that situation. And then we'd be the same here, I think. And we'd also get 0 in there as well. And we get all of these. So we get a line going up here, for one. And get a line going here as well. And then we'd also get the same for, since it's in the real numbers, we'd also get the same for, no, wait. Wait a minute. We're going to get the same in a situation where, let's say y is negative. So let's say for the left-hand side, if y is negative and we subtract a positive version of it, then that's also 0. So we get, I think we get this as well, because minus 1, no wait, minus 1 minus 1 is not that, that's not right. Okay, so let's say x is minus 1. No, let's say y is minus 1, and we what do we have to subtract from minus 1 to get 0? We have to subtract minus 1. So that means we get this point. Painful. Painful. Just painful. Painful even to imagine. Imagine that. Okay, I think we get that. And then presumably it's on this side too. So let's say y is minus 1. What do we have to add to that? Yeah, we get this as well. Okay. Now, do we have any other lines coming off here? I don't think so. Can we get like any other points that come out of this? I don't think so. Okay. Jan says 51 is somehow opposite. 50 was forward. For each input x and y, they told you the point to plot. 51 is backwards. They give you all points, but are saying throw the points out when that equality fails. Can you write the set builder notation for the forward version of 51? An extra question. So you mean, Jan, you mean when you say the forward version, do you mean the difference between, like, let's say number 1 here and number 5, in that they're kind of opposite way rounds with the elements? Is that what you're saying? Oh yeah, I just got it. X does mark the origin. Yeah, you're right. Yes, 1 and forward is 5 back. Okay, right. So your question is, or your assignment is, can we take this and write it in reverse? Versus this, which of course is this. I guess we want something that generates these. So it's going to have to be this. And it's going to have to be something in Well, we'll have to have something about elements. Have to have something in here. And so we want something that can generate this. Let's start with that. And then well, one way we could do this would be to say that x and y are the same. So we could have that, I guess. That would get us this. That would get us that way round. And then, yeah, you could flip it, right? So you could say, yeah, I guess this is where your hint comes in. So let's say x is in the, well, x has to be in the reals. And y has to be in, sorry, I'm covering up with my head. It'll be closed, it'll be -1 and 1. Do we need to worry about 0 there? Don't think so. Maybe we do. If x is 1 and y is 0, then y would end up being so we'd end up with like a horizontal line, right, which we don't actually want. So I guess we're talking about the reason you've got those braces there is because this is a set, and that's set notation, not interval notation, which I only just clocked. What do you think, Jan? How close am I? Let's hope Jan didn't have to go anywhere. Anyway, very good. So I'm glad. I didn't believe I could do that one. So, all right, let's get 52 done. Then we can look at the answers, and we might be able to take a short break and then maybe move on to the Cartesian product. Okay. $52. All right, x and y are both in the real numbers, and then we've got y minus. We've got to equal 0 thing again, so we've got to work out when these is. Oh, got to miss that out. Then we got to work out when either of these is 0. So let's say this one is going to be 0 when y. Let's say we've got. Let's say y is 1. In that case, to get to 0 on the left-hand side, we can have x being 1, so we have a point there. Now when x is 2, x squared ends up being 4. Which means y has to be 4, which means we get this, I think. And then this would be a good one actually to have the bigger graph for, I think of it. Let me get my big graph back. Okay. So 1, 1, 2, 4, 3, 9, I think. Is that right? yeah, y has to be to be in this quadrant anyway, for this left one to be satisfied, y has to be x squared in order for that to be 0. So I guess another way of putting that, is this right? Y must be x squared in order to satisfy that. So that's like part of it. There's probably a whole other way of doing this. And then for the right bracket, well, let's draw this first. Let's actually try and do this properly. We end up with something like this. Something kind of like this. Yeah, okay, so there's that one, and then for the right hand bracket to be 0, if y is 1, then we couldn't actually make it 0. It couldn't be 0 at that point, because nothing squared is capable of subtracting out 1 by adding it. So in that case, y will have to be negative. Y will have to be negative, and then this will have to be positive. So there's nothing above the line for that one. We've got, let's say y is -1, and x will have to be, to subtract that out, x will have to be 1 as well. So I guess we're going to get something that's reversed, right? So if y is 4, then x will have to be 4 as well, which means x squared will have to be 4, which means x has to be 2. And then we get this, so we get a mirrored version. Oh, okay. Okay, and then is there anything else we need to consider? Do we have anything over here that we need to worry about? Let's say if y is, yeah, there is, because there's another solution for if we have y as 1, then we could also get a -1 for x, and that would get the same result. So we have this, and we have this as well, I think. So I think we get this. Another x marks the spot, I think. Okay. All right. Should we go and see what on earth the answers say for this? I think I've done them all now. All right. What a horrifying set of diagrams I have made. Oh, it's not following me anymore. Okay, here we go. 39. Bit laggy. Okay. Hopefully it doesn't lag too much. Okay. Well, 39 is incorrect. I guess this range here, this interval rather, is continuous. I was actually wondering what the kind of like default number is for these intervals. I assumed that it was the integers, but I guess it's not. I guess it is in fact the real numbers. So I guess that's the right answer for that, really. Oh, you said it before, the intervals are intervals of real numbers. I didn't get it. I didn't get it at the time. Ah, that's what you meant. Sorry. Got it. What birds have I got in there? Song thrush from outside. I don't know, actually. These are not my birds. These are the birds of... Okay, it really is lagging now. Come on. Come on. Okay, let me sort this out. Oh, that's not what I wanted. Okay, and where am I? There we go. Oh, it's the music of some... Music of this person. Or the sounds of this person. They are public domain, but attribution is requested, so I'm attributing them. But they actually do sound oddly similar to the birds where I am in real life. Okay, so these are... Okay, let me get my screen back where it was. They're intervals of real numbers. So this is actually a square, not a set of points. Intervals are intervals of real numbers. Okay. Lock that in. Right. Now, 40 we don't have an answer to, but we can assume that it's a block there as well, probably. 41 is a line. Again, same mistake as before. They're not the discrete points. In fact, I guess it would be kind of weird, honestly, if they had a whole syntax for just integer ranges, integer intervals. It wouldn't really make much sense, would it? Okay, 43. 43. Now, 43 was special because it's not a box, but it is continuous here. So, yeah, this should actually be this. Okay. 45 is the circle, but properly done. 47 is, yeah, this this horrible creation. 49. Yep, I think that's pretty close. Wow, I'm amazed that was actually right. Okay, and then 51. Oh, we don't get to see 50. That's a shame. 51 is the X. Okay, and we don't have any other answers. Huh. Down the 2, yeah. So we're on a side quest at the moment, going through the book of proof. But we will be we're learning the prerequisites of the art of computer programming. We got through the first section, I think. So it's volume 1, and it'll be volume 1 for probably a couple of years to come. Ah, it's time. Arcia says, there's a semi-famous maths physics joke. You can construct the single equation of the universe by taking all equations, say A equals 0 and B equals 0, where either one needs to be satisfied, and construct A times B. There is an equivalent construct where A and B needs to hold at the same time. Oh, interesting. Red Santa says, "Time to continue with Advent of Code." Yeah, well, it's the season for it. Yeah, I always think about going back and doing them all, but maybe one day. Potumusi says, "What processor will be used for running test programs when reaching the art of computer programming?" I'm not certain yet. I will probably develop my own, just to make it a bit visually interesting. Or do you mean process it in terms of the mix versus M mix? Maybe you mean that. I will probably try to do both and compare them. For those who don't know, Knuth's books come in two. They sort of come in two varieties. He invented two virtual processors, basically, assembly languages. One was called Mix, and the other M-Mix, which is a more modern one. And I think I will probably use both, just due to historical interest. Okay. All right. If I'm familiar with LaTeX, with Strauss, yeah, there is indeed a version of Excalibur with math support, with LaTeX support. Yes, I will try it out. Okay. I'm going to take a short break, and then we're going to work through this next section, the Cartesian product, and then we might get to some more exercises. In fact, we'll probably get to some more exercises pretty soon. Yeah. So I'm going to take a short break. You will get to enjoy the bird sounds. So I'll turn them up, and then I'll see you in, I don't know, 5 minutes, let's say. Hello. Alright. Where will I make the birds be now? Okay, I think they're okay. Let me know if the birds are ever too loud. Or if I'm too loud, turn me down, turn the birds up. Maybe they're talking about mathematics. I guess we would have no idea. Bird math. Okay. Now, it's time to read some more. So I'm going to do that. Okay. 1.2. The Cartesian product. Now, I've heard about this before. I might know it already, but I'm not certain if I do. Given two sets... No, I don't know about it. Given two sets... I've heard of it, I don't know about it. Given two sets, A and B, it is possible to multiply them to produce a new set denoted as AXB. This operation is called the Cartesian product. To understand it, we must first understand the idea of an ordered pair. Okay, we've got a definition. Definition 1.1. An ordered pair is a list of two things, x and y, enclosed in parentheses and separated by a comma. Okay. For example, 2, 4 is an ordered pair, as is 4, 2. These ordered pairs are different because even though they have the same things in them, the order is different. We write 2, 4 not equal to 4, 2. Right away, you can see that ordered pairs can be used to describe points on the plane, as was done in calculus, but they are not limited to just that. The things in an ordered pair don't have to be numbers. You can have ordered pairs of letters, such as L, M, I guess that's L, hopefully L, ordered pairs of sets, such as these, even ordered pairs of ordered pairs, like these. The following are also ordered pairs, these, oh, they're heterogeneous. The real numbers and 0, 0, oh my gosh. Any list of two things included by parentheses is an ordered pair. Now we are ready to define the Cartesian product. Definition 1.2. The Cartesian product of two sets, A and B, is another set denoted as AXB. Hopefully that's how it's pronounced. Pronounced? What am I trying to say? Pronounced? Denoted as AXB and defined as AXB equals a set of these ordered pairs where A is in B and B is in B, set B. A is in set A and B is in set B. Okay, so what this would mean, I guess, is that if we have a set like... Okay, where are we zoomed in at? Let's try this. If we have a set like... Okay. So what I was wondering is this related to like matrix multiplication? And it feels like it could be. So let's say if we have these, but I don't know yet. I'm not a linear algebra head yet, although I will have to be at some point. Okay, so AXB is going to be equal to AB, where A is in A, and that's how we say and, I guess. B is in B. So the resultant set is going to be it's going to contain 1 and 3, 1 and 4, 2 and 3, and 2 and 4. It's going to have 4 elements. I think this is true. I don't know this stuff, so don't view this as true. It's just me trying to figure it out. I think this is right. And this is like, is this kind of like combinations, maybe? Maybe. Not really, though. Because combinations, you just have one set, as with permutations. But it's kind of, that's kind of the mental operation I was doing there. Okay, fine. Let's see if I'm right. Thus, AXB is a set of ordered pairs of elements from A and B. For example, if A equals K, L, and M, and B equals Q and R, then we get KQ, that's K and Q, K and R, that's those. I guess this is also how you multiply out brackets, right? In algebra. L and Q, L and R, M and Q, and M and R. This seems like... Yeah. Wait a minute. Okay. Right, so figure 1.1 shows how to make a schematic diagram of A, X, B. Line up the elements of A horizontally, and then line up the elements of B vertically, as if A and B form an X and a Y axis. Then fill in the ordered pairs so that each element is in the column headed by X and the row headed by Y. Okay, fair enough. Diagram of the Cartesian product, that's fine. For another example, 0, 1, X, 2, 1 equals those lot. If you're a visual thinker, If you're a visual thinker, you may wish to draw a diagram similar to figure 1.1. The rectangular array of such diagrams gives us the following general fact. If A and B are finite sets, then the cardinality of AXB is the cardinality of A multiplied by the cardinality of B. Okay, so the size of AXB is basically the size of both multiplied, side of each one multiplied. And then we've got some dice. Somebody's got the dice characters up. Let A equal 1, 2, 3, 4, 5, and 6 on dice be the set consisting of the 6 faces of a dice. The Cartesian product AXA is diagrammed below. By fact 1, 1, which is this, or by simple counting, the cardinality of AXA is 6 multiplied by 6, which is 36. We might think of AXA as the set of all possible outcomes in rolling a dice 2 times in a row. Each element of the product is an ordered pair of form result of first row, result of second row. Result of first roll, result of second roll. Such constructions are useful in the study of product probability. I just stumbled there because I was trying to think about what do you do if there are duplicates. But there shouldn't ever be duplicates in this situation, I don't think. Like duplicate ordered pairs, because you're just enumerating over the first set and the second set. So you shouldn't ever end up with duplicates unless there are duplicates in one of those sets, and there shouldn't be duplicates in one of those sets. So there shouldn't be duplicates in a Cartesian product either. Okay. The set RXR, so we're doing the Cartesian product of the real numbers and the real numbers, which is this, should be very familiar. It can be viewed as the set of points on the Cartesian plane as drawn in figure 1.2a, which is this one. The set R by n can be regarded as all the points on the plane whose second coordinate is the natural number, so that's these lines here. This is illustrated in figure 1.2b, which shows that Rn looks like infinitely many horizontal lines at integer heights above the x-axis. The set natural numbers by natural numbers is the set of all points on the plane whose coordinates are both natural numbers. It looks like a grid of dots in the first quadrant. That's this, as illustrated by figure 1.2c. Okay, makes sense. It is even possible for one factor of a Cartesian product to be a Cartesian product itself, as in the real numbers by the natural numbers by the integers. We can also define Cartesian products of 3 or more sets. We can also define Cartesian products of 3 or more sets by moving beyond ordered pairs. An ordered triple is a list such, such, and such. The Cartesian product of the 3 sets Rn and so real numbers, natural numbers, and integers is this, which is this. Of course, there is no reason to stop with ordered triples. In general, such and such. Well, okay, let's spend a bit of time on this. A1 by A2 by etc. to AN is equal to the set of triples, no, of not of triples, of tuples, I guess we probably would call them in programming. I don't know if we have numbers for, I don't know if we probably have words for these, but I don't know what the word is for an n length version of this, where xi is in, where x, this, xi is in ai for each I in up to n. Okay, fine. That seems pretty obvious. Be mindful of parentheses. There is a slight difference between, okay, all right, so what's that called again? There's a rule. It's like in those words, like commutativity or something like that. Associativity, that type of thing. There's a slight difference between this and this. The first is a Cartesian product of 2 sets. Okay, so we're going to get ordered pairs. We're going to get, what are these called? Ordered pairs. We're going to get ordered pairs out of this, whereas we would get ordered triples out of this. Okay, so it's not, yeah, it doesn't work anything like multiplication really, in that sense. The first is a Cartesian product of 2 sets. Its elements are ordered pairs. The second is a Cartesian product of 3 sets. Its elements are ordered triples. To be sure, in many situations there is no harm in blurring the distinction between expressions like such and such, but for now we regard them as different. I should hope so. I should hope you would regard those as different. Very upsetting for the programmer in me to have people regard these as the same. For any set A and positive integer n, the Cartesian power an, oh, it's like, it's Cartesian product repeated, essentially. Okay, so it works like multiplication. Powers are kind of multiplication repeated. Okay, fine. I guess that's fine. Okay, fine. In this way, r squared, so the real number squared, that's the notation we saw earlier, is the familiar Cartesian plane, and r cubed is a 3-dimensional space. You can visualize how, if r squared is in the plane, then integer squared is a grid of points on the plane. Likewise, real cubed is a 3-dimensional space, and integer cubed is a grid of points in space. Okay, interesting. Wow, this is this definitely. I do enjoy when the exercises require sort of require knowledge that you are going to learn in the next section. I know that sounds sarcastic, but it is true. A lot of learners do not like that type of thing, but I actually quite enjoy it because it gives you an emotional resonance that, like, oh, okay, that makes sense now. All that weird stuff in the last exercise, that makes sense. Okay. In other courses, you may encounter sets that are very similar to real n, but yet have slightly different shades of meaning. Consider, for example, Red Santa, have a good day too. Thanks for joining. Have slightly different shades of meaning. Consider, for example, the set of all 2x3 matrices with entries from the real numbers. M, that's a set of matrices where we've got a matrix. I don't know much about matrices, but that's a matrix. UVW, all these in the real numbers. This is really not all that different from the set this. So r to the power 6. Okay. The elements of these sets are merely certain arrangements of 6 real numbers. Despite their similarity, we maintain that m is not real number to the power 6 for 2x3 matrices are not the same things as sequences of 6 numbers. Okay, makes sense. Same data, different structure, I guess. Represent the two sides of a coin. Okay, example. Represent the two sides of a coin by set S, heads and tails. The possible outcomes of tossing the coin 7 times in a row can be described with a Cartesian power s to the 7. S to the power 7. A typical element of S7 looks like this. Yeah, I remember this. Meaning a head was tossed first, then another head, then a tail, then a head, followed by 3 tails. Note that the cardinality of S to the 7th power will be 2 to the power 7. That makes sense. It's like the rule we saw earlier, but put in power terms. So there are 128 possible outcomes. If this is not clear, then it will be explained fully in chapter 3. Oh, excellent. Okay. And then we got some more exercises. Interesting. Jan says, so they have you plotting very nice sets right now, but there are absolutely some wild ones out there. Take a look at the Cantor set, the Julia sets, these other sets I can't pronounce, and the famous Mandelbrot set. Happy Norris says N tuple. Ah, yeah, okay. Yeah, that makes sense. I've heard that before. Ben Chilling 1. Hi, I have a question about the memory allocation video if there's time for it. Yeah, go ahead. I don't promise to have the answer, but I will try to answer it anyway. Yeah, I remember that video. That was the one where we talked about... Probably, I mean, it could be a few of them, but I imagine it's the one we talk about dynamic arrays and the optimum dynamic array resize factor. Maybe it was that one. It might be a different one. Do let me know if not. Okay. And then we got a relatively short number of exercises. We might even get these done. Okay. Exercises for section 1.2. Write out the indicated sets by listing their elements between braces. Okay, this is going to be real dull. Okay. Alright, well, it'll be real dull. If it's real dull, it'll be real fast. So let's just bash it out. Okay. One A. So A by B, we've got 1A, 2A, 3A, 4A, and then 1C. Oh, it's time. 2C, 3C, 4C. Okay, I think so. That makes sense. We should have the number of elements times the number of elements. So 4 times 2 is 8. Makes sense. Apart from no, that is right. Okay. A by A will be, oh, this will be even longer. Okay. 1, 3, 1, 4. And it's going to have 2, and then 3, and then 4. I think that's right. We switched to curly braces. Oh yeah, we did. Okay, well this will be good motivation to not get it wrong next time. Because these are not sets, these are ordered pairs, so the braces are important. Need to learn to do that properly. You know, if I was using Vim, I guess this would be super... If I was using anything other than Excalibur, this would be super easy. But then it wouldn't be as motivating to get it right, would it? Wow, that was quick. 3, 4, 5, 5. That means it must be 5 PM, right? Wow, it'd be cool if I synchronized this up with the real time. Unless they're just testing it. Okay, 1C. Alright, let me do a bit of organizing to get this away from my head. Probably just move these over. 1C. Oh, you know what I did? I went the wrong way. This is 1C. That's 1C. 1B doesn't bode well, does it? Is this book by Richard Hammock? Yeah, it is. It is. This is Richard Hammock's proofs book. Yep. It's available online for anyone to read. So I recommend downloading it if you are interested in that. Okay, B by A. Now that's not going to be the same as this, but it will be the same size. So let's see. So B by A, we have A by 1. Wait, let me get this right in my head. A by 2. No. A by 2. No, A by 2. Come on. A by 3. A by 4. And this is different. It is different. And then B, oh sorry, C. I think that's right. Yeah, right number of elements. Yeah, okay. Let's slot that in there. Then we're going to do D, which is this one. B by B. No. Okay. B. Now this one is the empty set by B, so it should have no elements because 0 times anything is nothing. Anyone else mix up their E's and their 3's? I'm not dyslexic, but I do that. I was tested for dyslexia repeatedly at school because they really wanted to believe I had it, but I didn't have it. I just make mistakes all the time. No excuse. Okay, so this F1, we've got to get A by B, which we already have. That was number 1. Okay, so we've got to get this, and then we've got to do... We've got to take this, and then we've got to multiply this by B. So we end up with 1A, 2A, I think, 3A, 4A, I think we end up with that. And then we do this, we get the same thing here. No, that's not right. We don't. We keep going. C, 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 C. And then we do all this again. But with C on the end. I think that's right. Hello, Yanshifim. This is not the other Knuth book. This is the Book of Proof, which is I'm studying en route to going back to the mathematical prerequisites. So I'm going to get as far as the induction section in this book, which will take some time, and then reapproach that. Try better, try differently. How are you doing, Yanshifim? AOCP does not recommend doing this book first. AOCP recommends that you skim over the mathematical part, and maybe if we ask Knuth what he would recommend if we wanted to understand more of the maths, then he would recommend we study concrete mathematics, which is another book he was involved in writing. I would imagine he would recommend that. But I'm being somewhat of a completionist, so I think he's probably, it's a good question actually, what he would recommend. But in any case, Yanjifim, doing well, thanks. Good luck with the maths, thanks. Glad you're doing well. Okay. 1F and then G. Now G is B by B, which we have already. That's the answer for D. Let me get rid of this. Is that correct for 1, that you have tuples for 1f? Let me take another look at 1f. I think it's right. Oh, the subtuples. I think so. I think so. The book earlier says there's a distinction between. Let me triple check this. There's a distinction between. Where is it that it says that? Yeah, so in this form we end up with this. I think that's the idea. Yeah, I think the book hedges a bit and says some people wouldn't view those as a distinction, but in this book we do. So, all right. Thanks for the question. Okay, 1g. Now this, we've got b by b, so we're going to have to multiply this by, or product this by a, which means we're going to first have 1, then a by a. Can't be doing all these spaces really. Then 2, a by c. No, wait. A by c. Two A by c. No, wait. Come on. We're going through the first one first, then the second one. Okay. Okay, so we start off with this, and then we do this. Yep, 3, 4. Is this right? I think so. First things first, indeed. The brain wishes to move on. The brain resists giving deep attention to these things in some ways. Okay. All right. That seems okay. And then, oh, we're running into some other... Uh-oh. Okay. Messy. No. Okay. All right, let me move these around a bit. I've been watching the video game Donkey Resident Evil streams lately, and this reminds me of the inventory management part. Okay. Right, now b cubed. 1h b cubed. Now b cubed is going to be, well, I can probably just do this straight out. Now this will be a. So this is not nested. A, C, I think. Then it'll be A, C, A, C, C. Then C, A, no. Gosh, okay. Now it's going to be 2 cubed elements, which is 8 elements, so this is not looking right. No, it will be right, because we're going to do all of them again. Okay, A, and then C, C, A, and C. Oh wait, that's not right. C, A, C, and then C, C, C. That's 8. 8 seems right. Oh, okay. Now let's put all that away. Bye-bye. Let's put that away. Now we do the same thing, but with different symbols. Oh, great. 2A. Most exciting stream on Twitch right now. Okay, A by B. So we're going to have... Oh, I got to even write all the symbols. Do I have one? No. Alt. Okay, do I have one for E? No. No, there's nothing for it. I'm gonna have to create a new symbol for that. Oh yeah, I guess I can just use E. Thank you, Bubble and I guess E is probably the practical choice. Okay, I'll just use the regular. I can just use the regular E. I guess that's not as fancy, but still fancy. I'm gonna do it. I'm gonna do it. I'm gonna do it. I'm gonna do it. I'm gonna copy that fancy E from Happy Nora, which I can't do actually because my stream client won't let me copy paste. And I'm going to make a replacement for it. It's just the same E. There's not even any. There's no fancy E in this font. There's no fancy E in this font. It's just the regular E. It's just the same E. Okay, alright. We'll just use the regular E. It's fine. It's fine. I want it to be fancy, but it's fine. Guess I'll have to make my own typesetting system about it. See you in 10 years. Okay, alright. So, alright. That's fine. That's fine. I can deal with it for now. I guess I am having my own special version of Knuth's making his own typesetting system, but my own whiteboard system. I just, you just really want to do it, but I also really don't want to do it. Okay, anyway, where was I? A by B. So let's do this. Okay, that's that. And then we want to have the E here. And then we want to have the 0 here. 0. Okay, that's... We can have a bit more screen real estate now as well. Okay, so that's 2A. Let's look at 2B. B by A is... We start with 0, and then we do pi, then 0 and E, then 0 and 0. Technically the pi is italic as well. I guess you're right. Are we allowed? Nah. Nah. No. I'll leave it like that. Okay, and then 1. Okay. Let's look at 2C. 2C is A by A, which means we get pi by pi. What am I doing? Pi by pi. Pi by E. Pi by 0. And then we do the same thing with E. And then we do the same thing with 0. And then we do the same thing again with B and B. So we end up with 0 by 0, 0 by 1, 1 by 0, and 1 by 1. That's for D. For E, we end up with the empty set because we have the empty set in it. For F, are these just the same? They are just the same. No, actually, the last one is different. The last one's different. Okay, so for this one, we're taking A by B, which is the first one, and then we're multiplying that by B. So we're going to have pi and 0 by 0 with 0. Pi and 0 with 1. Pi and 1 with 0 and 1. E and 0 with 0 and 1. I think I'm doing this right. E and 1. 0 and 0. 0 and 1. Alderman the Drive says, are you doing all the exercises? I'm doing... at the moment I'm doing all the exercises. I may not stick to doing all the exercises for this book. It depends how easy they get, I guess. For the Art of Computer Programming, when I get back to that, after this mathematical diversion, then I will not be doing all the exercises, but I will be taking the exercises seriously. The reason I'm not going to do them all is because some of them are unsolved research problems, and I don't expect I will be able to solve them. Yeah, it will take me forever. This project is going to take a long time. Sheetcasts, I think. You're welcome. Yeah, as Sheetcast is mentioning, I upload the VODs to YouTube, and they will become a fairly long archive. Part of the I could also stay doing math forever and ever. Yeah, there's a risk of that. In a way, I want this to be like not exactly the same in scope as what Knuth does in producing the books, but like comparable in scope as a reader. Like, it is a big deal to be able to read and digest and understand the majority of Knuth's The Art of Computer Programming, I think. Like, it takes a lot of work, and part of this is to kind of show that, I think. Yeah, we're missing. Yeah, my sense is we're missing something in this. Okay, pi and 1, pi and 0, so pi and 0, pi and 1, e and 0, e and 1, 0 and 0, and 0 and 1. Yeah, no, wait, this is all wrong. This is all terribly wrong. I got distracted at some point. That's what happened. Okay. E and 0 with 0 and 1. E and 1 with 0 and 1. 0 and 0 with 0 and 1. Well, if only there was some machine that could do this work for us. And then 0 and 1 with 0 and 1. So we should end up with as many... So we should end up with twice as many elements as are in here. And we've got 1, 2, 3, 4, 5, 6. We've got 6 elements here, and then we double that. Okay. Should be 12, yeah, that's right. Yeah, so there are. Okay, that's 2F, I think, done. 2G. What do we got here? A by B and B. We've got B and B somewhere for 2D. So we want to have A by that. So we're going to have for each of... Yeah, let's try and transform this. So with this, we're going to have to put pi on the beginning of each one and a bracket on the end. Window management again, okay, and then this is going to have E, and then this is going to be 0. So we have 1, 2, 3, 4 by 3, 12 elements again, which makes sense because this should be A by, so 3 by 2 by 2, so 3 by 4 is 12, okay, fine. That's 2G, a bit messy. Oh no, we're running into this again. And then 2H. So this one is different. In this case, maybe there's a way we can translate this across. Is this just the same as this? I mean, in theory, maybe. I'm not like 100% convinced. I think it probably is, but I just want to check that it is the same. Okay, so let's say we start off with pi, and then we start off with, so it's A by B by B. So we got pi, and then 0, and then 0, yeah. Then pi and 0 and 1. Then pi and 1 and 0. I think it's just the same without brackets. I think it is. And then in principle we get E here. Oh, 1, Just one. First quarter of the hour, I guess. Wherever this is. Yeah, so I think it's the same without brackets as the result. I think. But, you know, in a different structure, of course. Okay. Okay. Oh, and then we got loads more to do. Adrian Bepp, hello. I am well, thank you. How are you? I think my brain has about, I'm going to say 30 minutes of fuel left. That's the feeling I'm getting in my mind right now. Okay. Well, that was a big lot of stuff again. How did I do math for 3 hours? People were watching me, so I felt bad about stopping. Life hacks. It's amazing. I mean, you know, you're working for me now. You're basically, you know, those things where people have, like, they hire a boss to, like, watch them. They don't even, like, have a, because they're working solo. They want someone to just, like, you know, observe them so that they do their work. I need some gamer fuel. Yeah, I do need some gamer fuel. And that brings us to this week's sponsor. No, I don't. I'm not sponsored by Feastables or anything like that. But Jimmy Beast, if you're watching, what on earth are you doing with your life? You're busy. You've got a company to run. Okay, all right. Enough. 3. Now, this is probably going to get more confusing. Oh, no, it's just more of this. Okay, this is dull. All right, if I can do the first few, I'm gonna just hand wave it a little bit. Okay, x squared. Okay, for the elements where x is an element of the real numbers, x squared is 2. So where x squared is 2, x is root 2, and okay, option V. Root 2 and minus root 2. This seems a little odd. I guess why not? I guess you can't always game the exercises to work out what they're expecting, and then we're going with 1 C, A, C, and E, and so we're going to end up with basically a set of, you know, root 2 A, root 2 C, root 2 E, etc. And we do this like this, I think. I guess the tricky part of that is the negative. That's what it's trying to get us to think about. Okay, 4. Yeah, I have currently had 1.5 Sports Direct mugs worth of coffee in this stream. So that for me is already a fair amount. 4. Okay. N in these integers. So that's going to be greater than 2 integers are 3 and less than 5 So that multiplied by n in the integers where the absolute value of n is 5, so that's minus 5 and 5. And so the result is this type of thing, I think. Yeah, I don't know why I did it the way around. Why not, I guess. Just my brain getting tired. Okay. Five. X in the real numbers, where x squared is 2, multiplied by x in the real numbers, where the absolute value of x is 2. So that's going to be, again, root 2. Multiplied by minus 2 and 2. Or, I suppose, if you want to be fancy about it, it could be, we could imagine, oh no, we can't because it's in the real numbers, so that's fine. I was just imagining it could be something of cardinality too, but it can't really. Let's leave it at that. We can assume that that's, let's not bother wasting our time drawing that out, because we know we can do that. Okay, and x in the real numbers, where x squared is x. Okay. Well, I know 0 squared is 0. I know 1 squared is 1. Are there any others? I feel like I remember there might be others, but probably not. If there are, then I'll learn something new. And then x in the natural numbers. So just 1. And let's assume we can do the expansion of that. I hate sleeping. Good username. Hi, I'm very well. I'm very well, thank you. How are you? Anita. Hi there. First time being here. Are you a teacher? I am a teacher, though I'm not studying things that I teach. So I'm a learner in this, but I am actually a teacher day to day. But I train software developers essentially. So I call myself an educator, but I'm not an educator in every topic, of course. Oblidon says, it follows from the cancellative property that 0 and 1 are the only idempotents. What's the cancellative property? Anita says, do you have any advice for junior developers during this time of AI and no one can get a job? Do I have any advice? In the abstract, probably if I was to guess at who might be listening to this, who is a junior developer, it would be tough to narrow it down. However, in terms of the job market, I would investigate in your country. So in the UK, we have something called apprenticeships. And basically it's a scheme where your training is paid for by the government / the employer, and you get a job with training. So essentially you do some training / and then, or alongside, you get a job, and the job typically lasts a couple of years. I think the apprenticeships we have in the UK and in other countries, there are other schemes that do some similar things, are a very good idea. And so if you can hunt down the companies, the employers and training providers that do things like apprenticeships where you get a job with training, then I would highly recommend trying to get to one of those as much as possible. Those are where I generally advise people look, particularly if people ask me. So sometimes people ask me, because I used to work for like a coding boot camp in the UK, And people sometimes do ask me who are in like the I'm thinking of learning to code position. I would say look for apprenticeships. Apprenticeships are the big thing you want to put your focus into. Probably don't pay for training yourself at this point unless you have a lot of money and you're willing to wait a long time for a job. So there may be things like that. That's usually my advice to people in the UK. In other countries, there are probably other schemes, maybe, that have things like that. But it is a tough time to be trying to get into the industry, for sure. So you have my positive vibes on your quest. Yeah, there's no channel commands here. Though I could add some. I don't know what I've never looked into it. Okay, anyway, 7. Okay, empty set times an empty, no, wait. That is the set of the empty set. That is not the empty set. So in this case, now what is that symbol? I guessed it. Alt-O. Okay, so this is... Okay, so this would be empty set 0. Empty set... Oh, no, we've got another one. I didn't even think of that. Empty set 0... 0? This one I'm going to write out because it looks kind of interesting. This one, empty set 0, yeah, and then, so this one, yeah, this one's the empty set again here. So this would be 1 times 2 times 2, which is 4. Okay, great. Anita says, is it still worth getting a CS degree? I'm 27, thinking about starting a degree in AI or ML, bachelor's degree, but I don't really know if it's still worth it and if I'm too late. What do you... this may sound like an obvious question, but it's still relevant to my answer, I guess. What do you want to get into the field for? Like, do you want to get into this field because, like, primarily because it's a career opportunity, or primarily because, I guess the reason I'm asking is, some people it would be okay if they never got a job out of it because they're that interested in it. For some people, that's not the case. Most people, that's not the case. So, if, for example, you're looking for a job primarily and a career and a means to economically support yourself, is the degree a good decision? Well, I was once asked to debate. I was once asked to be part of a debate with the Vice Chancellor of the University of Pretoria, I think. University of South Africa, actually, I think. And I was given the thing I was supposed to argue for, which was a university education is the worst investment a young person can make. That wasn't a position I chose. It was a debate in which I was told what my position would be, and I had to argue for it. And there are some good points that university education can be a dubious decision. I think if you're 27, you've got a little bit more, because you've got more career experience, you've got an advantage there. So university education might be a better choice, but I would be strongly looking at as many statistics as you can find about what the outcomes of those degrees are, because certainly in the UK, this was a couple of years ago, before AI, computer science degrees had amongst the worst employment outcomes of any degree for employment within their subject, for employment within the field that they were designed to train, which is kind of stark, really. You'd think that they would be very good at getting people jobs, but they were actually very bad at getting people jobs. So you want to go in eyes open on whether it's your particular institution you're interested in, or the statistics in your country about the employment outcomes of computer science degrees. as to the chances you have, and also being realistic about your own skill. Like there are some people who, any job market, they will get a job, and there are some people who that's not true. It's not true for me, for sure. I'm not like one of those people who's a mega genius and can get a job in any job market. Yeah, I need to send me an email. My email is, if you email this email, send me an email there if you like, telling me a bit about your situation, and I'm happy to give some more detailed advice. I won't promise it will be necessarily good advice, but I do know a bit about getting jobs in this field, so I may be able to say something useful. But yeah, do send me an email. I'm happy to give it some more in-depth thought. Okay, 8. 0 and 1 to the power 4. So in this case, we're doing the Cartesian power. And so we're going to go with 0, 0, 0, 0. And then, well, we're going to expand this out. I guess we're going to have 2 to the 4 elements, which is 16. So I'll do the start, and then it's going to look something like this, I guess. Yeah, so it's, something like this. ... Okay, let's have those. Let's consider those done. Oh, no, that's not right. And then there's more sketching. Oh my gosh, more sketching. Okay. Let's just do a little bit of this. Let's try and make this reasonably swift. Okay, maybe we'll learn something from this. Okay. Okay, 1, 2. Rusty, thanks. Thanks for watching. Okay, 1, 2, 3. So this is going to be X, Y. Okay, so we're getting ordered pairs out of this. So we're going to be 1 on the X, 1 on the Y. Let that be red. 1 on the X, 1 on the Y. No, wait. 1 on the X minus 1 on the Y. 1 on the X, 0 on the Y. 1 on the X, 1 on the Y. Then 2 on the X minus 1 on the Y. Yeah, okay. And then we get this, right? So let's call this one B9. Or 9, I guess. 9 will be fine. Okay, let's do 10. Okay, for 10 we've got -1 on the X and 1 on the Y. So this, and this, and this, and this, and then this, and this. I think that's right. Let's go for 11. They're mirror images. Guess they are. Oh yeah, the mirror images are also in there, right? So I guess swapping the order, that's an interesting point. They, I guess the swapping them over mirrors them in X equals Y. Yeah. How interesting. Okay. Oh, now this is an interval, so it means it's going to be a line. The square brackets means it's a closed interval, which means it's inclusive. So we are going to be, let's say for 0, we have 0 and 0 and 1, so we're going to be bounded by this. Yeah, so 0 on the x, we get 0 and 1 on the y. 1 on the x, we get this and this, so we're going to end up with a square, I think. Yep, unit square, yeah, that's right. Unit square. And then I guess all of these are going to be like that, right? So -1. So this one started off at 0, 0, and then ended up at 1, 1. Does the same logic apply? Let me try following it and see if it does. -1, 1, -1 on the x, 1 on the y, and 1, 2, 1 on the x, 2 on the y. Okay, let's think about that more deliberately. Okay, so we have -1 and 1 is on the point. -1 and 2. -1 on the x and 2 is there. 1 and 1 is there. And 1 and 2 is there. Okay. Rectangles. Rectangle city. Yes. Okay. Different number of elements. And these are set elements, not intervals, in the first one. So we've got, let's think about the points. We've got 1 and then 1. We've got 1 and 2. We've got 1.5. And 1, 1.5 and 2. We've got 2 and 1. So this is kind of like the other ones where some of them were in the... Kind of like the other ones in which some of them were like in the integers and some of them were in the real numbers. So I would... Maybe these are lines? The lines in the y-axis because the y comes second because it's second in the multiplication. So I guess this is what we're looking at. Makes sense. Okay. Now the interval's on the start. Now in theory this would mean, well, let's try it. Let's try this out and see if it works. No. No. Let me think about this. So it would be like that, right? Let's try that out. So in that case, we start off with 1 on the x and 1 on the y. No, wait, 1 to 2 on the y. Okay, that's a nicer way of thinking about it. 1 on the x to 1 to 2 on the y. No, wait. Let's flip this around. 1 on the y to 1.2 on the x. 1 to 2 on the x. 1.5 on the y to gives us 1 to 2 there. and then 1 to 2 here. So it's always lines of 1 to 2. So I guess that's another way of looking at this, is it's always lines from 1 to 2 on the x-axis, and we're just putting them at different points in the y-axis. It's kind of a nice intuition for it. Yeah, indeed. Tally numbers for tally marks for the amount of hours spent. By the way, did you know? Anyone French in the chat can confirm. I think in France they do tallies like this, a little bit like this. So this is 1, this is 2, this is 3. There's probably a different way around. This is 4, and then this is 5. I think. Is that true? I hear that's what's done in France. That's French tallying. I always thought that's like way cooler than, I don't know, English tallying. French people confirm or deny. Okay, 15. Okay, so we've got just the number 1 on the x-axis, and then we go from 0 to 1 on the y-axis. So it should look like this. Well enough. There we go. It should look like that. Okay. French people do KO, not okay. Oh, really? They say KO for not okay. Is that true? Is that true? Are you messing with me? That sounds so cute. I guess maybe it's kind of fits the set theory. Okay. And then flipped. So we're going this way, I assume. Okay, now this one is the natural numbers on the x, which means it's going to be a line along the x for integer y's. So I think we're going to get basically this. I think this type of thing. And we include 0. Forgot to include 0. I think we get that. Wrong. Wrong. Natural numbers, not real numbers. That's why I'm wrong. Okay. Natural numbers on the x. That's that, for example. Versus integers on the y-axis. So something like this, etc. You know, you get the idea. Grid of points. Gosh. Should do this in MS Paint. This type of thing. Took a few extra off there. Does this book not include 0 in the naturals? As far as I know, yeah, I don't think it does. Though I have just been assuming that. I didn't even know it was an option to include 0 in the natural numbers. But I think it doesn't. Yeah, no. No zeros in the naturals. I didn't even know it was an option to not have to choose. Huh. Wow. I'm gonna start my my drama channel now. I'm like, some people have been telling me 0 is included in the naturals, and here's why that's wrong. Here's why, if you believe 0 is in the natural numbers, you just haven't thought hard enough about it. Bring Prime in here. Bring Hassan in. Get them all. Bring Knuth in here. Okay, alright, well I learned something from that anyway. Z by Z, Zintegers against the Zintegers. Okay, that's going to be just a grid, right? Oh, can't get that right. I'm just going to copy it. Just imagine that these are lined up perfectly. I think something like that. I kind of assumed because 0 is like not really natural. It's like made up. I guess that's why I assumed 0. Like I just didn't question that 0 wouldn't be in the natural numbers. Thanks, Happy Nora. Okay. Maybe yeah, maybe Richard Hammack hasn't he didn't know about 0 when he wrote this. That was new math. When they talk about the song The New Math, that's what this is about. That's what that's about. They hadn't invented 0 then. They had to invent it so they could have it in... Knuth invented it so he could use it so that computers could exist. Otherwise it's just 1, and you can only compute 1 with that, so... Very important. Okay. 0, 1, 0, 1, 0, 1. Now, this is going to be 3D. Okay. I'm gonna have to download a new reality for this next exercise. We're gonna have to use our human brains to process this image. Oh, there's not even any lines. How am I? Is there one with lines, maybe? No, the lines wouldn't even make any sense. How are you gonna... No, wait. Maybe there is. Maybe there is. Maybe this can help me. What do you think? Alright, let's see where it goes. 0, 1. This is an interval. These are intervals, so we're going to have a cube. I'm going to get my best cube drawing skills on. Come on. Okay. I think it's a cube anyway. Okay. And then imagine that's filled in. I think. So that's what, hello. We're just drawing the unit cube. I've discovered it. Discovered the unit cube. We're doing some set theory. We're doing some basic set theory on the road towards learning how to prove things, on the road towards learning how Knuth wants us to understand proofs in the art of computer programming, on the road to doing all of the art of computer programming. I should have a diagram for this. Yeah. It is hard to know. It is hard to know whether it's filled in or not. Yeah, I always thought category theory would be a nice... Yeah, hopefully it comes up. I'm sure it will. Okay, so let's say that's that. And then we've got one more. We've got 20 to do. Okay, so we're going to be in here again. Now, we've got... That's this one, by the way. We've got some XY coordinates. Yeah, and then they get multiplied out to make it, yeah. And then they're going to be in an interval 0 to 1. So, yeah, we're going to have this where x squared plus y squared is less than or equal to 1. Let me work out what that plots out to be. I've probably done that already, actually. Somewhere. Fairly sure I've plotted that out at some point today. So, yeah, so x squared, let's say x is 1. Y would have to be 0. And if likewise here. And then we have the same with negatives. It should be mirrored, probably. And we're going to be like in here, I guess, in this area. We're going to be able to have 0 in it if x is 0.25, y will have to be, yeah, y will have to be, yeah, if x squared is 0.25, y squared will have to be 0. Oh, the boundary of that will be y is 0.75. So we end up, I think we end up with like my intuition is saying that we end up with something like this. Maybe? But then what happens over here? I guess it's... Is it mirrored again, maybe? I'm not like 100% sure of this. I'm definitely feeling my mental energy resisting being put into this exercise. In theory, it should be this. Well, let's say my brain is telling me it should look like this. Let me graph this out so I don't totally confuse myself. Oh no, it's the square again. I got it completely the wrong way round. It's the square again. Okay, it's the square. No, it's not. Why am I saying square? It's the circle again. It's the circle. I can't believe I missed that again. Terrible. What am I doing? Okay. Well, I was pretty close. You just need to... The thing is, I just rotated it. That's the thing, I was in a different coordinate space. This is what it is. Okay, so it's the circle. It's the circle there in the 2D space. Now, what is it in the 3D space? Now, if it's the circle, it's tempting to say it's a sphere, right? That's the desire. Now, if we have a circle, now this is kind of an interesting point. If we have a circle and then we take it, let's say it's in these axes. Actually, is it X and Y? X and Y will be coming first and then Z will be coming second. So actually it won't be, it'll be flat. How on earth do I distort it to look right there? What does a circle look like flat? Oh my god, it looks so terrible. Okay, let me zoom out. Wait, I've still got some, yeah, I've still got some room. Okay, so it's like, I think it ends up like that. And then I think because it's continuous in the Z axis, and it's not changing, so it's just going to be a cylinder. It'll be a cylinder. Terrible. It'll be a cylinder like that, I think, but it's the wrong dimensions there. It should be probably a bit, you know, a bit bigger, I think. And it should be filled in, right? Probably. Should look like that. That's my guess. That's my final answer. Okay. Okay. All right. What are they saying? -1, 0, 0 should be in the set. Oh yeah. Okay. It's centered wrong. Yeah. Okay. Should be centered over. Yeah. It's really falling apart now. Okay, so it should be centered there. Somebody said it should be an ellipse. Oh no, wait, maybe you meant that it should be if we tilted it, it should be an ellipse. Okay. A cylinder. Okay. Seems like it's a cylinder to me. What are we saying? What are we saying in the chat? Some stuff about category theory. Yeah, category theory. There's a YouTube video I'm meaning to watch about category theory. Definitely, it's strongly related to Haskell, right? And I do know some Haskell. I learned some Haskell about 10 years ago, and it changed. It didn't change my life, but it did change the way I program, which is pretty close to life. Yeah, kind of spaghetti sauce. That's true. Okay. Wow. Well, let's look at some answers. I guess I am still learning things from these exercises. So, okay, a horrendous number of exercises there. All right, where are we at? Okay. Okay, it's lost me. It's lost me in the space that I'm at. Okay, it's found me again. Great. Let's assume I've got that right. Let's assume I've gotten that right. I think I've gotten that right. D. That seems right. These are all answered, actually. E, empty set. F, looks about right. G, looks about right. H, looks about right. And then we don't get answers for 2, we get answers for 3 though. 3 is root 2 minus root 2a. I guess he's ordered a bit differently, but I think it's the right. Oh, these birds are going wild. Let me turn this down a little bit. It's distracting me. Bubbledon, do I have a stream schedule? I don't yet, but it's typically Thursday afternoons London time. So about now, every week. But I will fix one at some point, but I'm just trying to work out what I can commit to. Thanks for joining. It's been great to have you in the chat. Okay, wait, where was I? 3. Okay, that looks pretty much right. I'm going to say that's right. 5 is... I'm going to say right. 7... Empty set 0, 0, empty set 0, 1. That's right. And then we have our fun diagramming problems. Okay, come on. Okay. That's correct. Oh yeah, we don't get an answer to that. That's correct. That's correct. That's correct. I'm going to say that's correct. And then we got this, the sphere, the square. But the square is wrong. Or maybe the graph is different? I think the coordinates are different. I think he's got... Does anyone know? No, there can't be any negative numbers in this cube, right? It wouldn't make sense for there to be any negative numbers in there. So he must be having the positive numbers come towards us and the negative numbers going away, which seems like not quite the right way in this solution. Just looks odd. But I think my answer is correct. I think. Apart from obviously, you know, he hasn't put all of the beans in his cube as well, which is a mistake in my view. Yeah, unlabeled axis, I guess. Maybe there's some of the other ones are labeled somewhere else and we'll be able to find out if it's just a mistake. No, looks like there's not that much 3D drawing in here. Anyway, let's assume that I'm right, because I would like to be right. Okay, now how are we getting on for progress? Okay. Our CR says, they didn't label their axes. Also, I only draw the arrow in the increasing direction. Finally, your drawing implies a right-handed system. There's a left-handed. Right-handed is usually the assumption in math. Okay. Thanks, Asya. Right, so then we move on to subsets, and after that we've got a relatively short number of exercises, hopefully not too arduous. Power sets, unions, yeah, I get that. That's pretty programming-y. Complement, no idea what that is, so I'll do that. Venn diagrams, we should probably spend some time learning a new notation. Index sets. I do have, well, ultimately there's no need for me to get through this at any speed at all, because there's no deadline, so may as well learn, right? Sets, yeah, and then after that it moves on to logic. Yeah, where do we end up? Kind of curious as to where we are in the sequence. Then logic. Logic will be fun, and then counting. Finally, I'm going to learn to count. All this time I've been just trying to envisage different collections of items. Okay, all right. I think that is where we're going to leave it for today. Thanks for hanging out. I've had fun working through lots of reasonably methodical processes with you. I have no idea why you would want to watch such a thing, but I'm glad you do. And thanks for all of the tips in the chat. Wow, a pigeon has just landed on my window. Okay, that was very exciting. Okay, all right. What this means is that it is time to consider who we will be raiding after this. If indeed you would like to stick around to see who we raid. All right. Now, who's in software and game dev today? And who is doing something interesting? Every time I feel like I choose anyone who's doing something weird, usually. It's kind of slim pickings, actually. A lot of game dev, but I'm not super excited by game dev streams. Nothing against... Oh, you know who it is? We can switch over to Soding. I was trying to look up how to pronounce that today. You can't go wrong, right? Let's do it. Have a wonderful rest of your day, everyone, and enjoy the next 10 seconds of the stream. And whatever Soding's doing today. Take care.